Hi, Chris Kuzmal here. We're converting a linked list into a binary tree. And the last two videos, what we did was we simply did a find and replace, where every time where before we were getting the next element in the linked list, we replaced that with getting the left child. And everywhere where we were getting the previous element, we replaced that with getting the parent. But that's ignoring the right child. And that's okay. And our search algorithm works. We pass 7 out of 7 tests using the test cases that are designed for a linked list. Now, if we look at the search algorithm, uh, what it does is if X is null or the keys match, and that's sort of the opposite condition to what we have here, then we're going to return X. And that makes perfect sense because X is the element within or the node within the tree that has a key that matches. But if we don't have a match, okay, but X is not null, then currently we have X being the left child. Well, it might be the right child. So I write the code to have X be assigned to be the right child. And of course, that's lovely, but we don't want line 11 and line 13 to both run. We need to make a decision as whether or not we're going to be making X the left child or the right child. And that's going to be dependent upon whether or not, because we're making this a search tree, we're guaranteeing that all of the elements to the left side are less than all of the elements to the right side. And so if our key is less than x dot, what is it that we get from x? I guess it would be the get key. So if we get the key from x and that value is more than the key that we have as our argument, then that means that we want to have x be the result of looking down the left side of the tree. Now, here's the thing. It's not going to, where before we simply looked at the left child and iterated, we did a while loop. Here, the situation is changed. We're not really in a position to do a while loop because we're having two possible directions to go. And so we are going to have to make a couple of changes to how we do this. The first change we're going to make is that rather than having this node X be established as the root always, we're going to require the user to pass in a node, which is our X, okay? And we get rid of line 8, which makes it always be the root. So on the first invocation of search, we would pass the root, and we might create another search method, which by default takes the root, or by default passes the root to this search. But for now, we're going to go ahead and follow what Corbin, Lisitz, and Revest do, which is to actually require a second argument, which is the node. And actually, they just to match their algorithm, we're going to put the node first. Okay. Okay. So now this only well, this is going to produce a problem in our test cases because our test cases are going to assume that the X is set. So what's our solution? Well, okay. What I'm going to do for so we're going to have to continue with this in the next iteration, the next video. And to do that, we're going to have to create another search algorithm, search method that calls this search method, so that our test cases work. And we're going to have to complete what happens here. We're going to have to transform this while loop into an if statement, and we're going to have to figure out what exactly happens. We're not going to be able to assign X to be the left child. We're going to do something very similar to that, though. We're going to be doing a recursive invocation of the search method, and we'll do all that in upcoming videos.